All right, let's get started here. This is the torque practice problems worksheet. It's pretty straightforward, pretty basic. All we're going to be doing here is going to be calculating the torque exerted by a force on an object. The object rotates about the black circle, so that's the axis. So again, this is, we're basically using this equation here. And just kind of just a little practice, get used to the equation, just so we're calculating torque correctly. So then that way, whenever we are, using it in other problems, this isn't going to be an issue. All right, so let's go ahead and get started here. So the first one, if I look at this is my axis point here, this black circle. So I know the force is applied 25 centimeters. So if I go ahead and use my equation here, I plug in. Radius is going to be 0.25 centimeters, or 25 centimeters, so in other words, 0.25 meters. The force is 35 newtons. The angle it makes to the point, the lever arm, is going to be 40 degrees, so I can go ahead and put 40 degrees in there. That's going to make, and just plug in a calculator, make sure you're in degree mode, because we're using degrees, 5.62 meters. Pretty straightforward, pretty simple. This is just the key here is make sure you're using the base units and make sure you're getting the correct angle. Remember, it's the angle from the force to the lever arm. All right, so they're going to have that like a little bit of like geometry review in here, like what angle, how do I figure out the angle and stuff like that. So let's go ahead and look at this. I got a 40 Newton force, so if I go start my equation here, I got radius is 0.1, the force is 40, sine. We have to figure out this angle here. So if I look, let's continue this on. So I got two parallel lines intersected here. Alternate interior angles are equal. So if I continue this on, in other words, the lever arm, I want to know that angle. So if this is 40 because of the alternate interior angles, then that has to also be 40 because of vertical angle theorem. So I know the sine is going to be 40. Okay. So I plug that into my calculator. I get 2.57 Newton meters. All right. So let's go scroll down here. Okay. Next one. So this one is pretty straightforward. I know that that's going to be at 90 degrees, so that's going to be my 40 degrees. So when I plug it in, I got radius is 0.25 centimeters or meters. The force is 60, sine 40 degrees. Plug it in my calculator, I get 9.6 newtons. Let's go ahead and do this one. So here they try to confuse you by giving you two distances. Remember, it doesn't matter how long the arm is that you're rotating. It just matters where the force is applied on that arm. So I'm going to use the 10, 20. So I go here. This 0.1 meter, 50 newtons, sine 60 degrees. When I plug that in, what do I get? I get 4.33. Easy. They just threw a little, try to catch you on that little trick in there. Just make sure you look where the force is. The force is at 10 from the axis point. The axis. So you're good to go. All right. Scroll down. All right. This one is kind of hard to see and actually kind of visualize because it's in two dimensions here. But what's going on is it's 140 degrees. So in other words, a straight line is 180. So this gives me the angle here is going to be from here to here is going to be 40. So if I know this is a 90-degree angle, that this has to be 50 in there to make the 90. It's hard to visualize just right off there. So then this becomes straightforward. I got like I said, radius is 0.4, force is 60, sine 50. We said 50. And when I do that in a calculator, what do I get? 18.4. All right, let's go to this one. So again, we got to kind of, let's look at this. So I know my radius is 0.5. I know my force is 80 times sine. Let's see the angle here. So same thing, two parallel lines intersected. Alternate interior angles are equal, so this is going to be 55. If that's 55, this has to be 55 because of vertical angle theorem. So the angle you're going to use is 55. So when I use that, I get 32.7 meters. And the last two. Last two are pretty straightforward. This one's super straightforward. 0.25 is my radius. 35 is my force, sine of 60 degrees. I should get one of my calculators, 7.6 newton meters. And then the last one here is radius is 0.25, the force is 35, and the angle is going to be degrees. So I'm going to do that. In my calculator, I get 0.56. Sorry, 0.56. Now, again, you could make positive and negative. It just depends on which way you want to set it as positive or negative. I'm not worried. I'm just worried about calculating the value. And then when you're worried, when we're dealing with other torques, like say there's multiple forces acting on the thing in different directions, that's really when we're going to be worried about, positive and negatives. Counterclockwise positive, clockwise negative, whatever you want to set it, it's fine. But for this, I'm just worried about if you understand what angle to use, what distance you're using for radius, and knowing that it's force. So pretty basic, pretty straightforward worksheet here. Hopefully that was pretty easy. All right, thanks for watching.